Okay, today we're in 6.2, Properties of Parallelograms, on page 312. And the things that we're going to be studying about parallelograms are their sides, their angles, and their diagonals. Okay, so first thing we start with are the sides. Theorem 6.1 says opposite sides of a parallelogram are congruent. Okay, so that means that, yikes, undo that. The base here and the base here, opposite sides are congruent. Likewise, that side and that side, opposite sides, those are also congruent to each other. Okay, now if this was a rhombus, which is a special type of parallelogram, all four sides would be exactly the same length. Okay, but in a generally speaking, in a parallelogram, you can just say opposite sides are congruent. Now we can talk about consecutive angles. Now consecutive, the word consecutive means next to each other. So if I wanted to look at consecutive angles, this angle right here is consecutive to this one down here, those two base angles. Now, this says consecutive angles are supplementary. So if I know, say, that this one right here measures 100 degrees, then the consecutive one to it, the one next to it, has to measure 80. So if we think about it in terms like that, if I've got this angle down here and the consecutive one that I am speaking of is the one there up at the top left, if these are consecutive, this one here and this one here, and they are, then this angle up top here is an 80-degree angle as well. Which leads us to our next theorem that says opposite angles of a parallelogram are congruent. So this drawing is from the Quick Check 2. So this is a parallelogram. It tells you that this is a parallelogram. Find the value of y in parallelogram EFGH. Okay. So I just did not label it. You got E, F, G, and H. So if this is a parallelogram, then we know that angle E, which is opposite angle G, have to be congruent to each other. So I'll subtract 3y from both sides, subtract 4 from both sides, and get that y is equal to 11. Now that we know what y is, then we can go to either one of the angles, let's use this one, and sub in 11 for y and find out the actual measure of the angle. So don't forget that you may be asked to find the variable, but you might also then be asked to find either the length of the side using that variable or the measure of the angle using that variable. So we found what y is equal to, but our question did not stop there. It's actually going to be asking for the value of y and then the measure of the angles. And we only need one because they're both the same. So 6 times 11 is 66. Plus 4 is 70. So each one of those angles, E and G, are both 70-degree angles. Okay. So looking at the next theorem, which is on page 314, theorem 6.3. Now we're talking about diagonals, okay? The diagonals in the drawing here, the diagonals are that line there I just traced over in red and the other line here that I just traced over in red. Those are the diagonals of that parallelogram. They go from opposite angle to opposite angle. So here it says the diagonals of a parallelogram bisect each other. Doesn't say anything about being congruent to each other. We will have some diagonals in certain quadrilaterals that are congruent, but in a parallelogram, they are not. The diagonals bisect each other. So that means that this length here is the same as that length, and this length is the same as that one. So we actually have a system of equations here for this quick check. Okay? We have A is equal to B plus 2, and then we also have that B plus 10 is equal to 2A minus 8. Okay, so we have to use either elimination or substitution to solve this system. Because I have two variables, A and B, I need two equations in order to find the values of both the variables. So I'm going to use the fact that A is equal to B plus 2 in the first equation, and then in the second equation, I'm going to replace A with B plus 2. So I would get B plus 10 on the left, that doesn't change, is equal to 2 times what A is equal to. A is equal to B plus 2. So I can distribute. Now I have an equation that is in only B. The A has been replaced with what it is equal to in terms of B. Now I've only got B in my equation. So B plus 10 is equal to 2B minus 4. Now I'm going to add 4 to the left and subtract 1B from the right. And I get that B is equal to 14. Now that I know that B is equal to 14, A is equal to B plus 2, which is 14 plus 2, which is 16. So A is equal to 16 and B is equal to 14. So that means that the diagonal that has 2 tick marks on it has a length of 32. That's because the length A is 16 and B plus 2 is also 16. So the longer diagonal is equal to 32, and then the shorter one is going to be equal to, well, 14 plus 10, 24 and 24 is 48. And actually, I drew that orientation incorrectly. Obviously, 48 is the longer diagonal. So that should have been drawn like this instead. But either way, okay, 48 is the longer diagonal, 32 is the shorter one. Either way, use the fact that the diagonals bisect each other or cut each other in half. Okay, now this last theorem, I did not write it down because it is very wordy, but here's an illustration of the theorem right there. Theorem 6.4 says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so obviously AB, CD, and EF are the parallel lines because they've got these little red arrow things on them. Those 3 are parallel to each other, and the transversals are the other lines. Okay, So Theorem 6.4 says that if these parallel lines cut off transversals in congruent segments on one, then they are congruent segments on the other. For example, I'm just going to erase those two little tick marks there. For example, if BD, right here, and DF are congruent to each other, that means that AC and CE are also congruent to each other, okay? So we can use that theorem on the quick check 4, okay? So I can see that these lines are all parallel because they are marked that way. And the transversal here, that line right there, the transversal cut off congruent segments AB, BC, and CD all measure 2. So if those segments cut off by this one transversal right here, if those segments are congruent, that means that EF, FG, and GH are also congruent. So each one of these measures 2.5. So this particular quick check says, find the length of EH. Well, 2.5 plus 2.5 is 5, plus 2.5 is 7.5. So the length of EH is 7.5. Okay, there you go. Easy stuff.